Hello students, welcome back to AriserTalent. I am your maths teacher Arpita Sharma. Students, we are studying polynomial chapter, right? Okay, so starting with writing the name of our chapter, which is polynomial. Okay, so this is our chapter that we are studying and we have covered some good portion of it and we were doing some questions on it. So, we have basically done with this part that type of polynomials and denotion and degree of polynomial. Okay, after that we are going to we were doing some questions on division theorem. So, here is another question on division theorem, which is find the remainder when, okay, have a look at that like this. Okay, now find the remainder when this is your what is this given? Px. So, Px is given x cube minus a x square plus 6x minus a is divided by x minus a. Okay. So, this is the question. Now, we have to find it. We have to solve this question. So, here is the solution of that question. What we have given, what we have provided with, what we have provided with. So, given, what is given? Px is given. Px equals to x cube minus ax square plus 6x minus a. Okay, and gx is given x minus a. That means we have to divide this by this. Okay, okay. So start doing that. This x cube minus ax square plus 6x minus a. Now students, by x minus a, okay, what you have done, what will you do? X cube minus x cube by x, that will give you x square here, okay, multiply this by this, that will give you x cube minus ax square, okay, subtract it here, sign will change, minus and plus here will cut and cut here. So, here remainder 0 will note this 6x minus a, 6x minus a, okay. Now, what we going to do? Checking the degree, x here 1 1. So, that means degree is 1. So, the degree is 1. So, divide this 6x by this x and get 6. Now, 6 is here. So, you will just write plus 6. You are having a positive sign, no sign, that means positive sign. So, 6. So, now multiply this 6 by this. So, that will give you 6x minus of 6a. Now, sign will change, minus and plus. So, that will cut and that will be plus of 6a minus a, that will be giving you 5a. That means your remainder is, my dear student, 5a, which is your answer. How can you check this? How can you check this? So, you can check this here also. If this is a factor, that will become x equals to a. Now, at x equals to a, p of a will become, that should have to be 5a. Let us check whether it is 5a or not. That will be a of cube minus a x square 6a minus a. Okay. Now, that will be converted into a cube. Again, this is a cube plus 6a minus a. Now, you, me, we all know that that will cut and that will become 5a. Now, this is the same we are getting here. That means this is well good. Okay. We have done this question. So, you can just cross check that also. So, you know now to find the remainder when something is given. Okay. So, done with that question. Understood? Now, what will we do? We will move toward the next question. And what is the next question here? Let us see. So, check whether this is a factor of this or not. Something is a factor of something or not. Okay. How will you know that this is a factor? let me tell you with the basic. I have told you, if you are having something as remainder, okay, and when you put the value of that factor, the value of x of that factor in this p, in polynomial of x, let us suppose this is gx, that is equals to x minus a, and you will put x equals to a, then pa will be equals to what? Some value here. Now the value of pa will be equals to rx if it is a factor, okay. Now student, it is clear to you that this particular equation follows, okay. Now it has been asked, check whether this is a factor of 3x cube plus 7x or not. What you have to do is just divide this and get your remainder as 0. I will tell you the second method also, but first stick to the plan A. So talking about the solution of this, 7 plus 3x, is this a factor of that or not? Okay. So basically this is our px and this is our gx, right. So px here and gx here. Now order of gx is important. I have told you, whether it is px or gx, that means divisor or dividend, you have to write it in correct order. That means the highest order degree term first, then the second highest degree term, then the third highest degree term, and so on. That means descending order of powers, okay. So here that will be writing as 3x plus 7. Now I have told you to multiply this 3x cube. So 3x cube by 3x will give you nothing but x of square. 3x cube, 3x, x of square, okay. So x square, after multiplying this to x square, will get 3 of x cube here, but plus of 7 x square, not 7x. So you are not going to write it beneath it, no, there is an x square term too. So we will minus it, that will cancel out, minus of 7x square. Now this plus of 7x will be the remainder here, okay. So carry forward. Now you are having minus 7x here, simply minus of 7x here, and here you are having 3x, here you are having 3x, that will give you minus of 7 by 3x, minus of 7 by 3x, okay. So minus of 7 by 3x here. Now minus of 7 by 3x here, multiply by, it is multiplying by 3x plus 7. So that will give you this minus 7x square, the first term, then the second term will be minus of 49 by 3, 7 7s are 49 by 3 here and x here. So that will be your next term, okay. Here you will get minus of 7x square minus 49 by 3 x. Now will you change the sign again, yes or no? Plus, that will cut. Now what are you getting? 7x plus 49 by 3 x, 7x plus 49 by 3 x, okay. Now you are getting a term in x, and this is 1 degree and this is 1 degree, so you have to do it again, okay. So you will get this 49, I am doing it rough here, 49 by 3x plus of 7x, so you will get 49x plus 21x, that will give you x 10, 5, 6, 7, again x 10, 0, 1, 5, 6, 7, so 70x by 3, Okay, so that will give you 70x by 3. Now 70x by 3x here and 3x here. So what will you do? You will just simply divide it by 3x and will get 70 by 9. So 70 by 9, okay, plus, okay, plus 70 by 9. When you multiply this 70 by 9 here, okay, so you will get what? This was here 70 by 3x. Okay, now what will you get after multiplying it this to this? You will get 70 by 3, okay, of x, then plus of, multiply this to this. So that will be 490 by 9. So now minus minus that will come as 49. So there is what? Remaining a remainder. It's here a remainder. Okay. If it's a remainder, that means I'll talk about that this is Px, this is Px, now this is your Gx, this is your Qx. After having that, you are having some Rx. That means you are having some remainder, whatever it is. But the question has been asked that check whether this is the factor of this. Now, if I forget this Rx, if this Rx is 0, then Px equals to Gx multiplied by Qx. In that case, I can say that yes, Gx is a factor of Px and Qx is a factor of Px. In this case, I am getting some remainder. That means neither of these two are factor of Px, because it's only possible when Rx equals to 0. Here clearly Rx is not equals to 0. That means we are having some remainder. That means it is not a factor of given term. So the answer will be no, because Rx is not equals to 0 here. In simple term, I will tell you, if I ask you that whether 9 is a factor of 81, whether 9 is a factor of 81, this is the first thing, and the second thing is this, that I am asking you that whether 9 is a factor of 80. In the first case, in the very first case, you will say yes ma'am. Why? Because if it is cutting it 9 times and having no remainder. In that case, okay, 8 is remaining here. We are having some remainder here. That's why this is not a factor of 80, and we are having no any remainder here, because 9 cuts full 9 times by 81. So whether it's 9 times or 8 times it is cutting it by itself, that means it is completely divisible by this. That means this is a factor of this. 9 is a factor of 81. In this case, 9 is not a factor of 80, simply because we are here, we are getting some remainder. In this case, we are not getting any remainder, right? In that particular form, it's very easy to understand, right students? 81, 9 nines are 81, then 0. If 0 is remainder, so yes, it is a factor. If 0 is not a remainder, anything else you are getting, that means it is not a factor. Here in this case, we are getting some, no matter what, but we are getting some remainder, that means it is not a factor of given expression or polynomial. Now next topic, Okay, enough of division theorem. Now we will talk about factorization of polynomial. What? Factorization of polynomial. Okay, it is factorization of polynomial. Okay, so in this case, in this particular topic, we will learn to factorize polynomial in one or two ways or maybe many. Okay, so let's start with the very first step. What is factorization of polynomial? What is factorization of actual number? Factorization of a number, that means if I will tell you in today's lecture 81 is my favorite number. So, if I write 81, so what is factorization of 81? Factorization of 81 can be done in this way: 81 multiplied by 1, or I can say that 9 multiplied by 9 multiplied by 1 is a factorization. Okay, or else I can get simply 9 by 9, or simply I can say that 3 multiplied by 3 multiplied by 3 multiplied by 3, and that is prime factorization of 81. So, these are all what? Factorization of 81. I can say 27 by 3 is also factorization of number, and now this is what we are talking about, a particular number, but now we are talking about a polynomial. Now we are talking about a polynomial. If I talk about factorization, there is only multiple signs, right? Some term, let's suppose this is a term, some term multiplying with another term, this term again multiplying with this another term. Now can I write this 9 equals to 4 plus 5 multiply by 9 multiply by 1. Now this is again what? Factorization of 81. I will use these kind of concept, okay, for the factorization of polynomial also. Now we will say that these are numbers and we are talking about polynomials. There is some difference. Yes, there is a difference, and we will consider the difference too. Okay. So, I tell you that if Px is a polynomial of degree n such that n is greater than or equals to 1. Okay, if Px is a polynomial of degree n such that n, the value of n is what? 1 or greater than 1. Okay. So, we are not talking about what? We are not talking about the constants, right? If I write this 277, what is the degree of this 277? 0. That means we are not talking about constant, we are only talking about actual polynomials. Okay, 0 polynomial has been eliminated from this. Okay. So, and a is a real number. A is what? A real number. So, here if Px is a polynomial of degree n is greater than or equals to 1 and a is a real number. Okay. Now what? What I am saying that x minus a is a factor of Px, right, only if Pa equals to 0. X minus a is a factor of Px if Pa equals to 0, and This first point is this, second point and reverse of it, nothing else that PA equals to 0. In first case x minus a is a factor of Px if PA equals to 0. In second case PA equals to 0, then x minus a is factor of Px. Now what is this PA? Now what is this x minus a? Students, simply if you look into it, that x minus a is a factor of Px. Now I have told you if x minus a is a factor, understand this thing here, okay, come here. I have told you that the simple equation Px equals to Gx Qx plus Rx. Now I am telling you these are factors. If these are factors, I have told you we are having no any remainder. That means Rx becomes 0. That means simply Rx becomes 0. Rx is 0, then only Px is multiple of Gx and Qx. I am saying that Gx, okay, this is something x minus a. Okay, so x minus a multiplied by something is equals to Px. Simple. That means if I write this x minus a, that means the value of x is a. Okay. Now if I write x minus a, here if I am writing the value, look here, Px equals to x minus a and some Gx or Qx, whatever you want to take, right. Now if x minus a, because this Rx is 0, because these are factors, if these are factors, that means remainder is 0. Now if I put to PA here, that will be a minus a multiplied by Qx. Now anything multiplied by 0, a minus a is 0, sorry. So a minus a is 0, that means PA equals to 0. Simply x minus a is a factor of Px if PA equals to 0, and simply PA is equals to 0 if x minus a is a factor of Px. Okay. So this is the theory. Now how this theory is applicable? So we will do some question on that. So have a look on the question. Here our question is, where is our question? Wait, here. Determine which of the following polynomials has x plus 1 is a factor. X plus 1 is a factor, which of following, right. That means if this is a factor of this, that means if I find out the value of x from here, that is x equals to minus 1. So at x minus 1, if this value becomes 0, then this is a factor. If the value does not become 0, then for sure it is not a factor. This is the simple concept. Okay, we will know this factorization method. This is what we have learned here is what factor theorem. This complete theorem is what? Basically this is your factor theorem. Okay. And this is so simple. You are having two numbers and you multiply them, and these are called factor of that result. Same here. If two polynomials are multiplying to each other and giving some particular result, so that polynomial, okay. So these factors are here, and that will be the. Now the relation between these two will be what? If we will find the value of x from the any one of them, and we will put the value of PA here, then PA will become 0. Okay. If that's so, that means they are factors. If it does not follow that, then this means they are not factors. Okay. So should I rub this? You know this now? Okay. Now go back to the question, determine which of the following polynomials has, this is has, okay, mind it, x plus 1, okay. So, we are having for first px equals to x cube plus x square plus x plus 1. Yes student, be focused on that we have given x plus 1 for all, okay. Let's suppose this is gx, okay. That means x equals to 1 minus 1. So, p minus 1 will become minus 1 cube plus minus 1 square plus 1 plus 1. What I have done, I just replaced all the x with minus 1, okay, minus 1, simple minus 1. So, minus, all minus here. So, that should be 0. If it is 0, that is a factor. Minus 1 cube minus 1, minus 1 square 1, minus 1, okay, plus 1. Now, 2 plus 2 minus, that will cut all and will give you a 0. P minus 1 is 0. That means, yes, it is a factor. X plus 1 is factor of this, okay. Now, for second we are trying x4 plus x cube, we will call it P1, okay. Now, this is our second number, that is P2 x, and that is given x4, x to the power 4 plus second number, that is P2x, and that is given x to the power 4 plus x cube plus x square plus x plus 1. Yes or no? Say again, the value is same, x plus 1 is given as the factor. So, you just have to write here P2 minus 1. Now, replace all x with minus 1 4 minus 1 cube minus 1 square minus 1 plus 1. Now, that will be even power plus 1, odd power minus 1. So, 1 minus 1 plus 1 minus 1 plus 1. So, minus 1 2 plus 1 2. So, that will cut by this, that will cut by this, what will get? 1. We get something which is not 0, that means this is not a factor. Okay, first complete, second complete, move towards the third one. So, the third one is, let us say it P3x, and that is given student x to the power 4 plus 3x cube plus 3x square plus x plus 1. Do not assume the values, just put the value here, x is x value minus 1. So, P3 minus 1 will be equals to minus 1 x to the power 4 plus 3 minus 1 cube plus 3 minus 1 square plus minus 1 plus 1. Okay, covered from there. Okay, now that will be 1 odd, not odd, even plus odd power minus, okay, minus 3 plus 3 minus 1 plus 1. So, minus plus cancel here, it is also cancel, but remaining with P3 minus 1 equals to 1. There is something which is not 0, okay, categorize with not a factor. The fourth one is P4 here, P4x, okay. Now, note it, x cube minus x square minus 2 plus root 2x plus root 2. Check the values, x cube minus x square minus 2 plus root 2 multiplied by x plus root 2. Okay. So now what you have to do, just put the value equals to minus 1 and get it like minus 1 whole cube minus minus 1 square minus 2 plus root 2 multiply by minus 1 plus root 2. Is that so? Now completely do the calculation, minus 1 here, then minus plus 1, okay, minus, now you can just multiply it, so that will minus minus will become 2 here, okay, minus 2. So that is minus of 2 minus of root 2 plus of root 2, that is here minus and minus, right. So that will be minus 2, minus minus is plus 2, minus minus again plus root 2 and plus root 2, okay. Is that so? X cube minus x square minus 2 plus root x plus of root 2, right. And here I will get minus of 2, so minus 2 and minus of root 2, minus of 2 and minus of 2 root 2, so minus here and so plus here basically and plus there also, right. So that will become, that will cut and that will become 2 root 2. So 2 root 2 is not a 0, that means this is again not a factor of x plus, not x plus 1 but the fourth given option. Noted completely? Noted. Now student, this is about the factors. We have done the factor theorem today, okay. We have gone through the division theorem and factor theorem. In next lecture we will find out some method, some type of factorizing the polynomial. This is not only one, this is not only a type, but we are having some particular type of factorization of polynomials, and we will go through some formulas, some interesting formulas also students. So we will get through this, but before that you just copy that all and have some good questions from AriserTalent sheet. And student, enjoy your life and don't forget to study hard. Bye bye, take care.